So anyway, here we are. We're still in the same area. So this is just north of Matagorda Island for you Matagorda Island team. So this is the same area onshore Texas with an expansion fault. And this is called the Stratton area. And that's what we talked about. So creating attributes is very easy. Every workstation does it. Again, the buttons will be different. But for example, in this case, I can come here and I can go to Trace Calculator. And then what I will do is I will have, of course, this is my 3D survey. I have a particular volume in here. And then I can scroll down and I can do a variety of attributes in here. And this happens to be, by the way, this is what's called Kingdom 2017. On the machine right next door, I have Kingdom 2020, where I have another probably 120 attributes, but that's okay. Right now, we're just kind of talking about the principles, but essentially it's pretty straightforward that you obviously define what your volume is and what kind of attribute you want to create. So let's just see here. In this case, sweetness. Now, we've had phases, I think it was last year, I don't know what happened. All the students must have shared a paper on sweetness because everybody was coming to the mid-project and final project presentations telling us sweetness was the answer to all the world's problems. So anyway, but essentially what you do is you pick your attribute. In this case, it wants to know which survey. So we're going to create a new type. Okay, one thing I will tell you, by the way, back to being practical. Once you start creating attributes, it's very hard to stay organized. So usually what I do is I take the actual attribute or the input attribute name, and when I create a new type, I just paste that in. That way I know that is the data, the input data that I used, and then I'll usually put like an underscore. So again, it's great to be know a lot of theory, read lots of papers, but you got to be practical on staying organized when you're doing your work. And in this case, it's now going to ask me, of course, where do I want to put that? And then this is a question, do I want to save it as 8-bit, 16-bit, or 32-bit? For now, I'm just going to go 8-bit. Now, when you're working on a regional scale, that can be okay. Of course, that saves you a lot of room on the workstation, by the way. But of course, when you come to final investment opportunities, you do want to go 32-bit, but I'm just going to do it here 8-bit because it's still going to be the 80% solution. The other thing, this is a quick aside. In this case, I'm actually working on the data itself in the workstation. You do have an option on most workstations to have what they call a brick type of volume. And that's one that loads very quickly into memory. And you can actually run your attributes on the brick volumes if you want. But in this case, I didn't run the brick. This is a small data set, doesn't take that long to run. But anyway, so there it is. So I've run my attribute. So now there it is, sweetness. There it is. So there's sweetness. And of course, we've said before, a lot of this now, it's all about, you got to look at it carefully. What's the gain? And, maybe you look at it with different color palettes, etc. But that's an attribute. So what does it tell me versus the input data? Well, that's for you to tie with the wells and make sure you understand the geology and so on. But that's the time data set that we started with. I also, before that, I ran the envelope, which is another one here for fun. And then I ran the frequency, so in other words, instantaneous frequency. So anyway, this is frequency. So again, these attributes, as you saw, they're very easy to create. But then the question is, how do you extract meaning from them? And so, of course, in part, it is in vertical display with the well information. So all these things we talked about in the last several seminars or work sessions, that's the key. You come down, you look at the logs and you see, okay, I see this higher value here, the black color here, so values of 380. What does that mean in terms of the geology? So now you're back to the wells and understanding those. Now, another thing I like to do is when I have key horizons is I actually like to extract the attributes along these horizons. So let's just see here. Oops, this is AB03, AB05. So we'll come back to that one. So I like to come in and just do an extraction. And so we'll say I've got AB03 and I'm going to throw in AB05 while I'm at it. And actually, I don't know what's in C38, but I'll throw that one in. And then you come in here and you say, for example, I want to pick these 3 attributes in each of those events. And so it's going to do its calculation here, hopefully. Okay, I'm going to put this to the side here. Anyway, the point is that all these picking, and you've all shown, lots of picking in here. What that means is that once you've picked all these horizons, you can select attributes that you think would be meaningful, and then you can extract various attributes along them. So let's take a look at AB05 here. And it does look like it's extracted those. So there's AB05, that's the purple event. So this is the time. And again, you've got to integrate. So you got to be thinking, in this case, we're looking at 2-way time. Structural highs are the orange colors. Those would, under normal circumstances, be your more favorable geologic areas. So we can then come in and look at, say, the envelope. And again, I usually like to, if I have an attribute that only has positive numbers, which is what the envelope is, I like to set it to 0 so I can kind of keep my bearings. So there's that one. Let's take a look at frequency here. And again, some of this, as we talked about last time, the art to see what's going on is actually working with the palette and making sure that you're showing as much of the detail that's in the data. And so that in part can be controlled by changing the end member values. Again, on this workstation over here, which is running a like 3-year more advanced version of the software, it actually shows me the distribution of amplitudes, and I can actually slide a bar on the left and right to control it. In this case, I'm just changing the end member values. And let's just come in and look at sweetness in here. So again, these are all just different views of the subsurface, right? And we already know now, I think I have my quote that pops up in white: there is no perfect data, or every data type is imperfect. So in the end, as an interpreter, you look at all these different data types, all these attributes, and you ultimately come back and tie it back to the wells. And you do that in part through taking, like we said, these arbitrary lines that will go through the wells where you've got the logs overlain. And usually you're going to end up coming to a very zoomed level. That is the other thing. Remember, seismic is relatively low resolution compared to the actual well logs. So here you are extracting an event, and let's, whatever, we extracted on the purple, but imagine we came here and we thought this black event is significant. Well, on our gamma ray, we see a variety of things going on. And so what may be significant at the petrophysical scale, this is often happening, is much smaller than your wiggle. And so that's why when someone looks at an extraction of something this big and they draw these great geologic conclusions, I really want to see you tied back to the well at the log scale. And this brings us back, by the way, to the well tie, why people always look for well ties. Now, the next thing that I often like to do when I've run some different attributes is to actually cross-plot them against each other, because I want to know, am I actually gaining anything from this? Or, by combining two of them, you can actually get more insight. So let's come in here. We had, let's say AB05. And all this is it's the same crossplot we used before in the logs, except this time we're using it to crossplot seismic attributes. So let's just say, if I wanted to crossplot frequency here, versus, let's say, the envelope here. And actually, sometimes I'll even plot it against, I'll put a color filter or put color in two-way time. So I do a lot of trial error when I'm in a place like this. And I mean like this part of the workstation. So again, remember we said it's all about the thinking. And trial and error, by the way, is a great thinking tool. So in this case, we do have our cross plot of frequency, instantaneous frequency, and there it is, hertz, versus instantaneous amplitude or envelope. And this has a lot of information. In fact, the most important information this happens to have is the frequency of the data at that horizon. And you can see here, this is 30 hertz data at the level of that event I picked. So that's a pretty important piece of information. And then these frequencies, why does seismic data have higher frequency? Well, one example is if the beds get thinner, right? So one thing influencing a move towards these higher frequency values is thinner beds. Now, you can also have other factors. Again, unfortunately, Mother Nature is not quite as simple. Higher frequency equals thinner beds. Fluid content can change this. Porosity can change this, but at least this is the thinking you have to undergo. And this is why, again, when you're back to the wells, it's critical to be checking. You know, you can have a hypothesis, nothing wrong with those, but then you need to make sure you're tying back to what's in the wells. In this case, I clicked to go to the default color palette where it checks all the values and it looks, so in this case, the color is telling me, as we said, two-way time. So I can see that the higher frequencies here tend to be associated with a deeper time. What does that mean? I don't know yet. Is that a depositional factor? Is it like when this was being deposited? Let's see, so 1.6 seconds, let's bring it over so you can have the palette. And remember, always use the palette. Any presentation, always got to have the palette there. So some of these deeper values, okay, so we see that they're coming in this northwest corner in here. So this is deeper, and for whatever reason, it's higher frequency. And I'm not going to pretend I can answer exactly why that is right now, but I'm just showing you that these kinds of displays and analyses, this is how you start to tie your wells to control your thinking. Another thing I like to do in here is to start digitizing polygons. So if I see something interesting, so like here is, for example, let's just say I'm going to come to the edge. I'm going to look at, say, here's some very relatively low frequency zones in here. And we'll just call it low. And we'll give it, let's see, usually blue color is what I like to go with for the low frequencies. And let's make the line thicker here so we can see it on the cross plot. Okay, so what I've done here is I have selected something that I think or I observe. This is just data, right? At this point, these are just pure observations. I see that there is a low frequency zone here on the left side of my plot, so to speak. And now I want to understand what that means geologically. And so having selected those, I now see those on my map. So obviously the next thing I'm going to do is if I see a group of events here that correspond to that crossplot space, I'm going to want to take an arbitrary line here. Then I'm going to want to come across, go through this zone, and then hopefully tie it to some wells. Now, I didn't check which wells have logs and which have tops, etc. But the basic idea is you come back to zones where you can calibrate yourself. So for example, you can see here, this is the zone of course, this is just one attribute, right? Sweetness. So here is where I'm getting lower frequencies. And then I come back up here and I don't have any of the little triangles. Then I come back to a little zone. So the idea here is you're going back and forth. And again, this was just one attribute. What if I want to see it versus the frequency itself? Now, in this case, the black and white color palette's not the best to illustrate those variations. But the main point is you cross-plot individual data types, you identify zones in cross-plot space that you believe could have some significance. If nothing else, it's the end members. If I don't have any geological hypothesis, I will come in and intentionally just pick end members. So that, okay, let's see what the lowest or this left piece of the plot is. And then usually you can pick this up, by the way, and you can move it somewhere else and then play with it, adjust your little nodes. And then you can go see another zone. And look at this, I don't know what this is. I will tell you, this is unrehearsed. This is my high wire act. I talked about the high wire act, right? So I'm making this up as I go along. But interesting, so here are these higher frequencies here, and I see they take on a certain shape. So again, I would want to come in, I certainly want to tie to wells, so I would be creating an arbitrary line. In this case, Murphy's Law, I have no wells right in the immediate area, so well, I'm gonna have to be practical. Come back here. I want to go down the guts of this thing because well, I don't know if it's a channel, but it sort of has a geometry like it. And you know, I want to come down here and take a look. So we come out here. Yep, so that's kind of the higher frequency zone. So let's just quickly do the palette here real quick. I'm going to go back to, I like the, what's called on this one, it's called the RSA color amp. That's a very standard palette. I think all workstations have a version of this. And again, it's not enough just to take the palette. Again, I've got to kind of work with the colors and see what's highlighting what I want. So a lot of working with color palettes. So when you get down to the real thinking, you know, it's a lot of working with those palettes. And then again, now I want to bring this back to the well and see what am I seeing in the wells themselves. And so your petrophysicist may have found a little zone in here that's 8 feet thick, and now the integration is across scales. That's one of the hardest integrations here, when they're finding things at 5 foot, 10 foot, and your seismic is seeing very broad things in here. So as I said, I'm not going to solve the problems or the exploration problems of Stratton here on the fly, but I mostly wanted to illustrate the principles. I'm going to do another thing here, which is to take a look. So, you know, as we said, like last year, we had a lot of enthusiasm because of the sweetness attribute. And let's see if I have my window open, by the way, the calculator here, because I think, is that it? No, that's my crossplot window. Let's pull it up real quick. So this is a tip, is that one of the best things to use is the help in these workstations. In DSG, I know decision space, it's a right-hand click. I think Petrel, is that the same place? Is that a right-hand click or is it an F key? I forget which. But almost invariably on these workstations, as you come in here, there are descriptions. So in this case, sweetness, if I want to know what sweetness is, it tells you it's the envelope divided by the square root of instantaneous frequency. So as we say, last year we had people, they kept coming to the mid-project presentations with sweetness. So, you know, I don't know what was going on exactly. So I would say, well, what's the significance of it? You know, why does that particular attribute mean anything? And in most cases, they said they didn't know. So when you come to a meeting and you show something and you say it's significant, like an attribute, make sure you know why you're saying it's significant. Now, there's nothing wrong with empirical. You could say, well, I did it 100 times and it always matched an oil well or a high porosity zone. That's okay, but be prepared for the question. What is the meaning of attribute XYZ? So let's do another quick cross plot here. So my question when they would show that is, does it really bring me much more than some of the attributes? And that's the real question, by the way. In most cases, I could spend my time studying 100 attributes. My gut feel is in most cases, the top 5 will actually answer 80% of the question, or maybe the top 10. It may vary from basin to basin. But let's just take our sweetness attribute. Let's take a look at that. And let's say, let's cross plot that against envelope. And frequency, say. Well, what do I see here? So let's finish what we have to do. Let's put our color palette. Never look at anything without a color palette. And let me see here. I'm going to play with the ranges because I'm only going up to about the green, so a value of 60. So let's just show a little bit more, in effect, dynamic range in our color palette. Let's see how it looks on it. Say if I do the top end at 60. Again, trial and error sometimes. Yeah, that's probably okay. So since the students last year couldn't tell me why sweetness was significant, we're going to answer the question ourselves. So actually, if you look at sweetness, it's linear with envelope. It's like if I do envelope, it's almost sweetness. Now, it's true, there is some variation in here because we're capturing, as it says, as we just saw there, it does incorporate frequency. And so in effect, you can see this is the 50 hertz piece of this, and then you go down in frequencies. But what I'm going to say is that is almost linear with envelope. So I'm going to say if I just use my run-of-the-mill envelope that I don't have to explain to someone, you know, envelope divided by the square root of blah, 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 that's probably the 80% solution. Now, you show me some wells and you calibrate and you show me why a specific zone in here is meaningful, you know, fair enough. You know, so if you come in and you say it's really important because this zone here in the sweetness display is tied to something in the well, whatever, we'll just call it, what is that? That's about 50 hertz. Oops. Yeah, helps if I type. And then if I come somewhere else in here in the polygon and I've got something that's meaningfully different, then there's a justification. And this is, what is that? That's about 18 hertz, I think, hertz. And in this case, the crossplot zones do also show up in the seismic. And we made them the same color, so I didn't change color. They're both red. We don't want that. We want one to be a different color. We obviously, let's put, say, cyan for the, which one is that? Cyan is going to be for the lower frequency. So there it is. So we can see in this particular case, the sweetness is picking up something here in this particular area. Again, I haven't done all the detailed work, but I would come back, I would look at the log, and I would go back to the map there and look where some of these different points fall. And then again, take wells that go through some of those points and calibrate it back to the wells. And that's the other thing. When you do things like this, by the way, choosing your palette or your colors is pretty tricky. So you can see I happen to have chosen a cyan, which happens to be hard to see at times if I'm in the green. So again, trial and error until you get really good aesthetics so that you can quickly see. But you know, if I took an arbitrary line and I went through those zones now that I've identified in one piece of my crossplot space there, and I come through wells, and then I come, here's the other piece here, there's the cyan, harder to see. So by the time I've done this and I've picked a cross section and I've gone through good examples of all of these, and if I can tie them to something specific in the logs, now I've got a real story. let's go back here. Let's go away from frequency now into something else. So I think that kind of completes at least the basic principles of what I wanted to show here. And let's just go to regular envelope. And now it defaulted back. I'll mention one thing, that because of the color conflicts or potential color conflicts like we just looked at on the map, I actually like, when I'm in vertical display, I like using black-white palettes a lot of the time. And that's because black-white is different than the color of your horizon. So you never have a red horizon disappearing into the red piece of your color palette, et cetera, et cetera. So I do kind of like the black and white palettes myself when I'm doing the basic work, whether it's things like the envelope attribute or even just the regular attributes. So anyway, I think that's basically what I wanted to illustrate when it comes to these attributes. Just think about them. Don't just believe them at face value, and ultimately prove them against your well data. Once you prove them, you got a story. Until then, you're basically just speculating, or you're just regurgitating what somebody else found worked in another basin, or it could be the nearby basin, but still, before you put your own money in, you'd probably want to make sure you understand why you're associating an attribute with something positive or negative. Yeah, now you see, we're going to show you here that, you know, some of you like doing stuff in Python, right? And all this. And remember that we can all become attribute creators, see? And again, we can all get PhDs and then go write papers on the attributes. So remember here, so Mr. Mohi, you know, you can come in and you can say, well, you know, our team's come up with some other great attribute that we think we're going to take, whatever, the input data, raised to the power of 3. Should have put that multiplied by, oops, sorry. Try again. Where's my multiplied by, let me see if it's going to let me do something else in here. Because Mr. Mohi, you're convinced you're now a sweetness convert, right? You're going to be using sweetness for the rest of your career. So let's put it in here. And you know, if it's good, what the heck? Let's multiply it by 6 or something, right?
Silent error.
Oh, do you want to add something else? What else should we add in here? Any other requests?
Well, I do not think so.
Okay. There you go. We're going to give you credit for this attribute. If you become a millionaire as a result of using it in your career, make sure you remember me.
Hope for the best, Mr. Allen.
Inshallah.
Inshallah.
I think that's finished. Get that out of the way. Man, I like that one. Now this one is interesting because what it does is it removes distractions, right? And remember, we said earlier, remember some of the teams talked about, we like to go from the general to the specific. And even though we just typed in some random things here, we're kind of making it up as we go along, but you know, it so happens we've done something that de-emphasizes a lot of the background, and suddenly it shows you some things that stand out very sharply here, right? So if nothing else, in this world where I could spend, your whole team could spend the next 5 years interpreting this, suddenly it's brought your attention to something. And so if I actually believed there was a geological reason for that, or if I tie this to wells and convince myself it means something, then of course now I can go and I can start mapping certain things. But attributes, or it's the same with workflows, anything that brings your focus to more restricted areas is helpful, because again, otherwise you could spend the next 5 years interpreting this. So this random Mr. Mohi attribute, if it turns out I come to my wells and I tie them and I see they happen to coincide with porosity, or my goodness, even better, pay, we're on the road, Mr. Mohi. We're going to be rich someday.
I hope so, Mr. Allen.
Yeah, so there you go. So I think that's it. So again, today I wasn't attempting to do real work. This would take, of course, a lot more thinking time, a lot more iteration. But I think you get the idea here of when you work with attributes. Don't think they're any magic solution to anything. They're not the end of the work. They're actually the beginning of the work. And so that's why, to me, it's like if you're lazy, you try and sell people on an attribute. But if you're doing multidisciplinary integrated work, you have a story of why that attribute is significant. You've tied it to the wells, and you really have a strong story.